and we're going to take a look at solving compound inequalities. Those are quite a few topics, but because this is all stuff that we spend about a chapter on in Algebra 1, they expect it to be reviewed for you. So when I look at this, I have x is greater than negative 5, which means you need to shade all numbers greater than 5. All right, so that's what that statement is telling you, to shade all the numbers greater than 5. So to do that, I'm going to go put 0 on my number line. Oh, I'm sorry, it's a negative 5. I got to look at my prints a little bit better. All numbers greater than negative 5. I apologize for that, guys. So what I do is I take the number that they're marking for me, kind of like my target, that negative 5. I'm going to put that on the number line. It's to the left of 0 because it's negative. I then also put its opposite on the number line. So that reminds me that positive 5 is to the right. I need all numbers that are greater than negative 5, which means I can't include negative 5, so I'm going to use an open circle for that. So we're going to use, for greater than and less than, we use open circles. If it's greater than or equal to or less than or equal to, we use the closed circles. If all I am is greater than negative 5, I can't include the negative 5, which is why it's an open circle.
Top of your notes should have that. Just go down the bottom.
So I know my page here doesn't necessarily match up. You might have to do something in the margins. So let's get that reminder down. If all I am is greater than or less than, then I'm open. If I'm greater than or equal to or less than or equal to, I'm closed. Ladies and gentlemen, the nice thing about this is x is on the left-hand side. And so your inequality is showing you which way to shade. All the numbers that are greater than negative 5 are going to be to the right. And so that's all we do. Alright, we have 3 is less than or equal to z. Not a big fan of this one, so what could we do with that to make it a little bit more user-friendly?
X.
X or z, doesn't matter. We could change it to an x, but there's something else I don't like about this. I can't change the numbers or anything. It's not the equal to, you can't change. There's something we can change about this problem, ladies and gentlemen. That's switch it. Good job. Flip it around, ladies and gentlemen. I'm going to write this as z is greater than. Keep it in the same position. So if it's open towards the z and pointing at 3. So if you need to, ladies and gentlemen, rewrite it so that your variable is on the left-hand side. What that allows you to do then is my inequality will always point me in the direction I have to shade. Because it's easier for me to understand I need all the numbers greater than 3 than I need 3 to be less than all my numbers. This one's a little bit harder for me to picture on a number line, but as soon as you tell me all the numbers greater than or equal to 3, I got it. I know which direction I'm going. So I'm going to go to my number line. We're going to put 0. And what other 2 numbers are we going to put on our number line? Negative 3 and 3. Open or close circle, Connor? Closed. And let's see, if I need all numbers greater than or equal to 3, am I shading to the right or shading to the left? Good job. Greater than goes to the right. And the inequality shows us. Any questions on graphing, ladies and gentlemen? Please read your read your directions carefully in the book. And I will look those over again to make sure there's no changes we have to make there. Sometimes you're just solving tonight. Other times you're solving and graphing. So please make sure you read them closely. All right, so let's take a look, ladies and gentlemen. We now need to solve the following problems. And what we need to remember is that if we multiply or divide by a negative, we've got to pay attention to what happens there. So I'm still, guys, I can draw a line through my inequality just like I do an equal sign, and I just start manipulating both sides. There's no distributing to do, so my goal is to get s on one side, the variable on the other. But this time, guys, I'm really kind of picky about where I move my variable. I want S on this left-hand side every time because I want my variable to be on the left so that I can shade a little more easily. So I am going to subtract the 5S from each side. I want my variable on this left-hand side. So what that's going to leave me with is negative 11.4 minus 3S is greater than negative 7.5. Don't lose track of 7.5. Don't lose track of your negative there. But now that we've done this, we're back to these little two-step equations. So I'm going to add 11.4. And this is where I needed you guys' help today because I got all these decimals. This is going to come down as a negative 3S is greater than, is that 3.9? Somebody check for me. Thank you, Isaac. 3.9. All right, Ms. Gorski, what's going to be my next step? Divide by what? 3 or negative 3? Which is it? You've got to divide by negative 3. But if you look at your notes, guys, it said, pay attention when you multiply or divide both sides by a negative. Does anyone remember from Algebra 1 what happens when we multiply or divide both sides by a negative? Well, this will change. This becomes positive. What's a negative divided by a positive divided by a negative? Negative 1.3. But something else happens, guys, simply because of the inequality. If you multiply or divide both sides. Okay, ladies and gentlemen, just because there's a negative in the problem doesn't mean you're going to do this. But if I am dividing both sides by a negative, you have to reverse the inequality. So that greater than inequality, now that I divided both sides by negative 3, is no longer greater than. What's going to happen when I reverse that? It becomes less than. I have to flip that inequality. So we get S is less than 1, negative 1.3. And that's it. Now I do want to check real quick in the book, guys. Your assignment's on page 45. If I take a look on page 45, I'm going to check and see if we have to graph these. They do want you guys to graph these. So how would you graph this? S is less than negative 1.3. What would I have to do? Obviously, you're drawing your number line, correct? Austin, what would I have to do? We're at number 3 because we need a graph.
Then you put like 1.3 positive, 1.3 negative.
Thank you.
And shape to the left.
Where's my open or closed circle going at?
Open.
Open. And then your inequality, guys. And this is the awesome thing about keeping S on the left-hand side. I need to shade less than negative 1.3. So the direction is just coming from that variable, from that problem. So the directions do say to graph, so you'll solve in that graph, ladies and gentlemen. We're getting you lots of practice with that. All right, let's take a look at number 4. I need to distribute the negative here. So I have 8x minus x plus 5. Make sure you get this plus 5 here, ladies and gentlemen. It is a negative times a negative. Make sure you get that positive. And then that's simply greater than or equal to x plus 17. Dominique, what should be my next step? Good job. Take 8x minus x. We get 7x plus 5 is greater than or equal to x plus 17. Hooray! What should be my next step? Good job. We want to move this right-hand side over to the left-hand side. Beautiful. Now, ladies and gentlemen, if you don't always move everything to the left, you still are going to get correct answers. You just have to think real careful about your graphing. So we get 6x plus 5 equals 17. Eric, what would I do next? Subtract 5. And then how do I finish it up? I've got 6x equals 12. Divide by 6. Oops, I don't have equals in here. Mrs. Woodard started making some mistakes in there. These are greater than or equal to. So I get x is greater than or equal to 2. Ladies and gentlemen, I'm not going to have you graph number 4. What I do want you to do is move on to number 5. I'm going to give you guys a little bit of time to work that out on your own.
So which one?
Nope, we're not going to do any more graphing until we get down to 6 or 7. If you wanted to rewrite it from the very beginning, yes, you could. So what would the rewrite look like if we wanted to do that?
Like 3 minus, or negative 3 plus 1 over 2x.
Good job. Now, guys, you wouldn't even have to do the whole flip like that. What you could have done is just pick this side up and move it over here. Keep it as 5 halves x minus 3. You just have to remember to then, when you move the 17 over here, make sure your inequality is still pointing at the 17. All right? So you don't have to rearrange every term. You just have to take your right-hand side, move it to the left, left-hand side, move it to the right. And then remember that inequality has to keep pointing at the 17. But that's not a bad thing to do there. Good idea. Guys, this one's a little bit easier because how many x's do I have? Just 1. So Tyler, when I only have 1 x, I'm going to have to get rid of this minus 3 first. So how do I do that? Well, how do I undo subtract 3? We're going to add 3 to each side. Good job. So I've got 5 halves x is greater than 20. How do I get rid of 5 halves? You can multiply it by 2/5. You can multiply by that reciprocal. How else can I get rid of that 5 halves x, guys? You can just divide, but what do you have to include when you divide by the 5 halves? Parentheses. It is so nice teaching juniors who already know that. My freshmen just look at me like they have no idea. You guys are like expert pros. So ladies and gentlemen, x is greater than what? This is why I told you to have your calculators out. You're multiplying by 2/5 or you're dividing by 5 halves. What do we get? 8. Good job.
Wait. Oh.
Okay.
You switched the whole problem around with changing the sign, so you like rewrite the equation would still be wrong.
So what do you have written on your paper right now,
I just
Austin?
added x less than
You cannot have it pointing at the x. That has to be pointing at the 8.
8. Fine.
So let me go. So you had this, correct?
Yeah, I just did it the way it was.
So you added 3, correct? So you had 20 is less than 5 halves x, correct? How did you get rid of the 5 halves? Divide by 5 halves. You put parentheses, correct? So you got 8 is less than x. Is yours still pointing at the 8 like mine is?
He didn't flip it.
Is yours still pointing at the 8? So how did you flip? Where you need to look because you somehow flipped your inequality in here, Austin, and we're not flipping our inequality because this is a positive 5 halves. I'm gonna guess that you accidentally flipped your inequality in there somewhere. All right, ladies and gentlemen, and inequalities include only the values that make both inequalities true. And so what I added in here is that you only graph their overlap. So the and inequalities are going to look like this shading between the two solutions. And you guys should have that already on your notes. We then have OR inequalities. And the OR inequalities include values that work in either of the two solutions. And what I put on here is that they don't have to overlap. But a lot of times, guys, our OR inequalities, when we look at them, we remind of like the oars on a boat where they're going on the outside. So the ands are in between together. The OR inequalities often go in opposite directions. So we've got two examples. Let's take a look at those. This first one, ladies and gentlemen, is it an and or an OR inequality? An OR, how do you know? Because it says OR. Those are the easiest way to identify, ladies and gentlemen. If it's an OR, it will say OR. If it doesn't say OR, guess what kind of inequality it is? It's an AND. All right, you guys have this down pat. So what I'm going to do, ladies and gentlemen, is I'm going to solve each of these two equations or inequalities. So I'm going to subtract 7 from each side. Do some quick equation solving. I get 4x is less than 4. And then I'm going to divide by 4 on each side. I get x is less than 1. Bring your OR with you. OR. And now we need to solve the other side. So basically, guys, I kind of like put blinders on. I only focus on the equation that's on that left-hand, or the inequality on that left-hand side, and I solve that. I didn't jump over the OR, focus on this inequality that's on the right-hand side, and solve it all on its own. So I'm going to add 8 to each side. I get 3x is greater than or equal to 24. How do we finish that up? Divide by 3. The nice thing about this one, ladies and gentlemen, is there was no reversing of the inequality. There were no negatives. Nope, we're going to do it all on one graph. Notice there's only one line on my... So what I'm going to do is I'm going to take 1, put it on the number line, and I'm going to graph that. What is x less than 1 going to look like? Well, is it an open or a closed circle? Open. In which direction is it going to graph? To the left, less than. All right, I'm going to graph 8. 8 is over here to the right of 1, correct? Quayshawn, is that going to be an open or a closed circle? I'm equal to, so I've got to close it in. And then what direction am I shading to be greater than? The right. Ladies and gentlemen, did you get a set of both ORs here? Yes, you shaded your OR correctly. Is that pretty easy? All right, let's do the AND one. Ladies and gentlemen, I know this is an AND because they share this problem in the middle. So all of the work that you do to isolate x, you have to share that with both inequalities. So I'm going to undo subtracting 15, correct? How do I undo subtracting 15? Add 15. So ladies and gentlemen, you got to share that wealth with everyone. Not only are you going to add 15 to 9, but guess where else I have to add 15? To the 12. That's what we mean by there's overlap. Those two inequalities being greater than or equal to negative 12 and being less than or equal to 9, they share this problem. So now I have to divide by 3. I have to share that with both sides. So I divide 24 by 3 and I divide negative 27 by 3. Negative 9 is less than or equal to x is less than or equal to 8.
Yeah.
I did mental math. Thank you. How about this negative? Does positive 3 work better there?
Yeah.
Thank you. So then this would be positive 1, correct?
Yes.
Thank you. I did 12 and 15. I apologize for that. Does that look a little bit better now, guys?
Yeah.
Woo! I did have some very concerned faces out there. That bothered me a little bit. All right, so ladies and gentlemen, the ants I think are pretty easy. I put 1 and 8. These both happen to be closed circles, ladies and gentlemen. They're not always going to be the same type of circles. You need to base it on what inequality is there. It's this greater than or equal to with the 1, so you put a closed circle. Less than or equal to with the 8, and then your shading is going to overlap. It's going to be in the middle, just like where was your X when the problem started? In the middle, and your shading's in the middle. All right, guys? Your assignment tonight, oh, that's just a blank page. Your assignment tonight is on the agenda. We said, nope, remember, we changed agendas, so it's now page 45. Numbers 19 through 21, those 3 problems, and then 26 through 46 evens. You're doing all of 19 through 21, guys, okay?